All right, I'm going to go through the review guide for the polars test. So we've got 4 conversion equations that you need to know. They are x equals r cosine theta, y equals r sine theta, and we also need to know that x squared plus y squared is equal to r squared, and that tangent of theta is equal to y over x. So in problem 1, we have to plot several points. The point A is supposed to be at an angle of 3 pi over 4, which is this angle right here. And its distance should be 5 away. And don't be confused in this graph. This is 1, 2, 3, 4, 5. So here's the 5 mark. So that's our circle. So if I go around the circle all the way to here, that's the point where A should be. 3 pi over 4 and a radius of 5 away. For point B, it's supposed to be at an angle of 5 pi over 3, which if you rotate all the way around will be this line right here. That's 5 pi over 3. And it's supposed to be a distance of 8. This is the 8 circle. So here's the spot where B should be. C should be at 5 pi over 6, 6.5. 5 pi over 6 is this angle right here. And then 6.5, we'll have to count. You go 1, 2, 3, 4, 5, 6. 6.5 is right about there. And that's where C is going to be. For D, we have to rotate negative pi over 2, which you mean to rotate to this line right here. And we have to go negative 3, which means we go through the pole and up 1, 2, 3 to here. For point E, we're going to go to negative pi over 6. Here is negative pi over 6. And then negative 10 means go through the pole, so we're going to go backwards. So 2, 4, 6, 8, 10. That is where E should be. F is supposed to be at an angle of 4 pi, so it's a positive angle. 4 pi would be 2 full rotations around the circle, so we're back here at the angle of 0 radians. Then we go 6 over, which is right about here. So those are our points plotted. Okay, so let's see if I can scroll down here. Next, we're supposed to find out where the location of point K is in 4 different ways. So first, K appears to be, if we do an angle of rotation that is positive, it appears to me that that's an angle of 2 pi over 3. And if you're having trouble figuring that out, remember that this top section is divided into 12ths. And so that means that this would be pi over 12. This would be 2 pi over 12, which is pi over 6. And if we keep counting, so that's pi over 6, 2 pi over 6 would be here, 3 pi over 6, and then this is 4 pi over 6. 4 pi over 6, if you reduce that, is equal to 2 pi over 3. So our angle for K is 2 pi over 3 in the positive direction, and the radius of K appears to be 8. And if you looked at the answer key, it says 7. That's a mistake. Another way we can get to K is if we rotate in the negative direction. And if you count, this will be 1 pi over 3 in the negative direction. It'll be 2 pi over 3 in the negative direction, 3 pi over 3 in the negative direction, and then finally this will be negative 4 pi over 3 with the same positive radius. Where people start to run into trouble is when we have these negative radiuses. And so the easiest way I can think to describe it is that here's where K is. Let's find out where K would be if we found 180 degrees away from it. And that would be the point way over here, and that actually looks like it's the same as point B. So this point right here. So what we're going to look at is, how do you get to B by a rotation? If we did a positive rotation all the way around to here, that would be a positive rotation of 5 pi over 3. But we don't stop here, because if we make the radius negative 8, that'll push us back through the pole and we'll land on K. The last way to get to that point is if we rotated this way to B, which would be at negative pi over 3. And then we would need negative 8 again. So that way we would go through the pole. one thing I want you to notice is that each of these are over 3. These are the unit circle angles for over 3s, and just some of them are positive and some of them are negative. All right, let's go to the next part, and this is where we had to do conversions. So to convert a polar coordinate to rectangular, you need to remember that this is an r, this is a theta, and we can use that x is equal to r cosine theta and y is equal to r sine theta to get the coordinates of our point. So in this case, that would be 14 cosine 148 and 14 sine 148. I'm going to bring up a calculator, make sure it's on. Come on, turn on. Nope, my calculator died. That's convenient. All right, let's see if I can kill it. Close. And we'll try to open it again. And I'll try one more time to get my calculator to work. Why doesn't my calculator work? Hey, there it is. It's alive. All right, so I want to type these into my calculator. I need to check the mode. My mode should be in degrees right now. Hit enter, quit. And I'm going to type in 14 cosine 148. Hit enter. And I get that the x-coordinate is negative 11.87. The y-coordinate, we do the same thing, 14 sine of 148, and I get 7.41. 7.41. So that should be the answer for the first conversion problem. Just make sure that you are in the right mode. I was in degrees. The next one, I want to switch to radians, because my angle is given in radians. But I do the same formula. It's going to be the radius times the cosine of the angle, and the radius times the sine of the angle. And if I type that in, quit out, it'll be negative 8 times cosine 5 pi over 4, and that gives me 5.656. 5.656. And if I do the same thing for the other coordinates, you'll get something very similar, but I bet it's negative. Nope, it's positive. Why is it positive? Oh yeah, that should be positive. I forgot that that would actually rotate back into the first quadrant. So that will be our answer. The reason I was wrong, 5 pi over 4 is down here, but because it's a negative radius, it actually goes up to here. So that's why those two coordinates are positive. The last two problems on this page, we have to figure out what the polar coordinates are of this given x, y coordinate pair. So the way we're going to do that is we're going to use the fact that x squared plus y squared has to equal r squared. So I'm going to very carefully type that into my calculator, negative 12 squared plus negative 5 squared, and that gives me 169. But I need to know what r is, so I'm going to square root both sides, and that's going to give me that r is 13. Show you real quick, square root of 169 is indeed 13. So now we have the radius. To get the angle, we're going to have to do the inverse tangent of the y over the x. And here we should double check our mode real quick. Usually these we'd like to have in degrees. A little bit easier to think of. Inverse tangent of the y divided by the x, and I'm getting an answer of 22.61. Now be careful, this point, negative 12, negative 5, is like here-ish. That is not the angle 22.61. The angle 22.61 is like this angle. So this is the case where you want to add 180. Which will give us 202.61 degrees. So the polar coordinates would be radius of 13, angle 202.61. You could give your answer in radians, but then you'd have to add pi instead of 180, which seems kind of complicated. We'll do the same thing for b. Go away. So we need to do the Pythagorean Theorem. We're going to do 6 squared plus negative 6 root 3 squared. That'll give us r squared. I'm going to do this carefully on my calculator. We'll do 6 squared plus negative 6 root 3 parenthesis squared, because I have to close off the parenthesis for the square root and a parenthesis that I had on the outside. If I hit enter, I get the number 144. So I need to know, when does 144 equal r squared? You take the square root of both sides, and you will get that r is 12. I'll show you that. Square root of 144, and indeed I get 12. To get the angle, we'll do the inverse tangent of the y over the x. And here you have to be careful again when you type it in. Inverse tangent of negative 6 root 3. Make sure you close that root 3 symbol. Divide that by positive 6. And we get the answer of negative 60 degrees. So let's check if that is okay. The 0.6 negative 6 root 3 is somewhere down here. That looks like a negative 60 degree angle, so that's okay. You'll notice my answer key actually says 300. If you add 360 degrees to this, you will get the angle of 300 degrees, which is equivalent to negative 60. So you could write two answers for this one. 12 negative 60 is fine, as is 12 300 degrees. Either one's okay. And that's the first page of the review guide.